So in this video we discuss tutorial 10 with properties of particle. For question number 1, which one of the following statements true about wave particle duality? That one says that light will have wave and particle characteristic but not at the same time, so the answer is A. And question number 2, electron and proton are moving and have the same de Broglie wavelength. Which one of the following quantities would be the same for the two particles? So de Broglie wavelength, the equation is lambda equals to h over p, because h is constant. So if lambda is equal, that means the momentum is equal as well. Question number 3, if the de Broglie wavelength of each of the following particles are the same, which of the particles has the greatest speed? Okay, so you know that if the wavelength is the same, therefore momentums are equal. P equal. So you can relate P with V. Okay, maybe I can straight away use lambda is equals to h over mv. Right. So lambda and h is equal. So V now depends on the mass. I can rearrange. So V is equals to h over lambda. Sorry, h over lambda 1 over m. Okay, since h and lambda is constant in this case, right? So V is inversely proportional to the mass. So if you have the lowest mass, you will expect that the velocity is the highest. So over here, the particle with the lowest mass will be electron. Question number 4, the Davison gamma experiment demonstrate the wave nature of electron. So it shows that electron can give you a diffraction pattern. Question number 5, why can't an optical microscope resolve smaller object when compared with an electron microscope? Okay, the actual reason is because light is of a longer wavelength when compared to electron. For question 10a, an electron and proton have the same de Broglie wavelength. So that one is a statement. So you can say that lambda proton is equals to lambda electron. And then it says that the question wanted to find which one has the greater kinetic energy, and they asked you to show or justify your answer. So you know that from the equation of lambda, this one is the one that is given inside the formula sheet. Lambda is equals to h over square root of 2 mev. Okay, then I told you that the ev you can replace with k, so it becomes h over square root of 2mk. M is the mass, k is the kinetic energy, because you want to relate with the kinetic energy over here. So if I use this statement that lambda p is equals to lambda e, then I can write it down like this. Just drag this one down here. Okay, therefore my h over 2mk square root of 2mk is equals to h over square root of 2mk. Okay, my left hand side is proton, so that means it is a mass of proton and kinetic energy of proton. Right hand side is electron. Okay, you can cancel out the h and square root of 2. Now you left with square root of mk on both sides. So cancel out this one. Okay, now obviously I can take square on both sides, so I left with meke equals to mpkp. Okay, if I want to relate with mass, so ke over kp is equals to mp over me. And then you know for a fact that since mass of proton is bigger than mass of electron, so you expect that this one is bigger than 1. Sorry, this one is bigger than 1. Okay, so if that one is bigger than 1, that means KE would be, I write it down. Okay, so if this one is bigger than 1, that means that the kinetic energy for this one is bigger than Kp. If I can write down, therefore Ke is bigger than Kp. Okay, for question B, they want to calculate the ratio of electron kinetic energy to the ratio of kinetic energy of proton. Okay, so basically this one is follow-ups to the previous question. So previously we already have this equation. Okay, we still have the same properties, which is de Broglie wavelengths are the same. So here they want you to find ratio of electron kinetic energy to the kinetic energy of proton. So Ke over Kp. So you have to read this one carefully. If it is ratio of proton over electron, so it would be the other way around lah. This one is upside down. Okay, anyway, so now you have to check the values for mass of proton. It's a constant. You can check it on the list of constant. It will be 1.67 times 10 negative 27. Okay, I use this value, and then it will be over 9.11. This one is mass of electron times 10 negative 31. Okay, use the SI unit so that you will get Ke over Kp, because this is a ratio, so final answer wouldn't have any unit. In 1.83 times 10 to the power of 3. Okay, for question 11, an electron is accelerated from rest through a potential difference of 1500 volt. If the potential difference is double, calculate the ratio of electron new speed to its original speed. So basically it says that the potential difference is double, so V capital is double. What happened to original speed? V small v. Okay, so you want to relate V speed and potential. So you can use equation of U equals to K, where U is equals to EV and K is equals to half mv square. So you need to have these two inside and inside the same equation, then only you can solve. So here I can rearrange V because they want to find the ratio of new speed, right? So V is equals to 2EV over m. Okay, it should be square, so if I bring the square to the other side, it becomes square root. Okay, so this is the original velocity. So the new velocity is basically, it has double the potential. So E, I can write this one as 2V. Okay, and then I can factorize the square root of 2. It becomes 2EV over m multiplied by square root of 2. Okay, 2EV over m is basically this thing, right? So I just highlight this one. So basically that one is just a V. So your V prime or your new V is V square root of 2. Okay, they want you to find the ratio of new speed to its original speed. So basically V prime over V lah. So if you press the calculator, you should get 1.41 something. Okay, and then question B, they want to find the ratio of electron new wavelength to its original wavelength. Okay, now you still can use okay, because you want to relate lambda. What is the question again? You want to relate lambda with V. Okay, so you can write, or you can use lambda equals to h over square root of 2 MEV. Maybe I copy the question down here. New wavelength to its original wavelength. Okay, Just put it over here. Question B. So this is my initial lambda. Okay, when V is equals to 1005. If V is double, then my equation becomes square root of 2 and e to V. Okay, again, you can substitute the values if you want to. So the ratio of electron, okay, so basically I can again factorize square root of 2 there. Okay, so basically this is just the old lambda, which is that one. So new lambda is equals to 1 over square root of 2 the old lambda. Okay, 1 divided by square root of 2 is 0.71. So the new over the old 0.71. Again, there's no unit because this one is a ratio.